of objects in a 3D virtual world with a 2D input device. Objects in a 3D world have 6 degrees of freedom. Even if you limit yourself to translation, you can control at most 2 of the 3 degrees of freedom with the mouse, so an object like this plant may float in space at some arbitrary distance from the user. Even if you could control the depth interactively, it would be hard to align furniture with the floor and walls, since you can't readily observe these alignments without changing your viewpoint. Now we turn on object associations. These are procedures that put some intelligence into objects, so that they know how to behave in natural and useful ways when dragged with the mouse. For example, one association called pseudogravity causes objects like this plant to sink down to a supporting surface. Note that natural and useful motion does not imply that we are constrained to physical realism. If we want to place lights or sprinkler heads at ceiling surfaces, we use an association called anti-gravity, which acts just like pseudogravity, except the object is aligned with the surface above it rather than the surface below. This behavior is very useful, even though it's not natural. Object associations are procedures that are bound to objects. They are called whenever the objects are moved in any way, and they control the precise placement and alignment of the objects at their destination position. The first job of an association is to disambiguate mouse motions in the view window into 3D motions in the virtual world. First, they choose an appropriate 2D surface for the object to move along. In the case of this cup under pseudogravity, that surface is the desktop. The mouse cursor ray is intersected with that surface, and the object is moved to the intersection point. This disambiguates the mouse motion into an appropriate motion of the object in 3D, so that the object may be dragged in an intuitive manner. But this simple relocation scheme, without pseudogravity association procedure, is not good enough if there are obstacles in the way, like for example this pile of books. The cup will slide through the books as if they weren't even there. For most application domains, this is not appropriate. The pseudogravity association will fine-tune the position of the object after it's dragged, such that its resting position is a valid one. When we reactivate pseudogravity for the cup, it will slide up on top and over the books rather than through them, which is a more desirable behavior for the cup. This whiteboard uses a different association, which we call the on-wall association. On-wall looks for nearby vertical surfaces and aligns the object's back with the closest vertical surface. This means the user is freed from explicitly turning the picture. They can simply drag it to the desired point on the wall, and the association takes care of the orientation and fine placement. The implementation of these mechanisms involves ambiguous trade-offs. Often it's not clear what should happen, and we had to make some assumptions about what other users might consider reasonable behavior. For example, what should happen if you slide a coffee cup off the supporting surface of a desk? Here we decide that the pseudogravity association procedure should move the cup straight down onto the next supporting surface, i.e. the floor. If you've made a mistake, you can move the mouse back to an earlier position and the cup will jump back up onto the table. If we want to move the cup underneath